Hey, did you know that the first street lighting was already available in Greece 1700 years ago? Well, as you might have guessed, today's topic is lighting. And lighting started a long time ago, as you can imagine, because fire is also lighting. The first controllable fire was in 125,000 years before Christ. And yeah, I know, right?
Wow.
That's so long ago. You can't imagine what that was like. The first lighting invention. But I wouldn't consider that real lighting. Do you?
Well, I guess making a fire is making your own light. So if you
You
can,
think it counts?
well, if you use it to light up a place, maybe in a cave or so, then sure, I would count it.
Huh, okay, then your first lighting was 127,000 years ago. Congratulations.
Nice.
Well, I wouldn't say fire is a real lighting. Lamps or oil lamps, I would consider that more like lighting. But that's also...
Yeah, but not even like a torch, because
I would say that is also an oil lamp, right?
well, you put a piece of cloth. You drain it in oil, so you could technically call it an oil lamp.
Yeah, it's more modern than the first ones, of course, but I think it's technically an oil lamp.
Okay.
Because the first ones, they are developed in 70,000 BC. Also, quite early.
That's only like 50,000 years later.
Yeah, it is. Well, it took quite some time, of course. Controllable fire to oil lamps. But they used shells and hollow rocks filled with animal fat. And how do we know that? I do not really understand how they do know that. But I can imagine it has something to do with the footprint that fat leaves over the years. You know, DNA that can be found in those shells and hollow rocks. Which is, yeah.
Yeah, that's actually pretty cool that somebody at some point thought, okay, let's put some animal fat on the fire. Maybe they saw some animal fat dripping on a fire and thought, hey, we can use that to make light.
That does seem logical indeed.
Huh. Cool.
Yeah, cool, isn't it? But those oil lamps were used in Egypt. The Persians used them, the Greek, the Romans, the Byzantines, all those big nations in the history of humans. And candles is the next step in the technology of lighting. When do you think candles were invented?
Well, I would say also a long time ago, but since we're talking 70,000 before Christ, I would say a couple thousand years before Christ.
Yeah, I would imagine that too, because a candle isn't that complicated, you might think. But
Yeah.
the first candle was around 200 BC in China, in the dynasty of Han.
Oh, wow.
So that's quite modern, I would say.
Relatively.
But they made
yeah.
it from, yeah. What do you want to say?
Yeah, I wonder how they made that, whether they used wax or not.
Something like that. They used whale fat to make wax, or something like it.
Okay.
Yeah, they used to hunt on whales for fish or meat, I would say. I guess they found out they could make candles out of it. I do not know how they did it exactly. Of course, it was 2,000 years ago. The old Europeans did something similar, actually, but they used beef instead of whales because, well, that's available over here, you know.
Yeah. Well, if you think about it, of course, to today's standards, it's not really nice to hunt on whales. But back in the day when it was more common, then why not use the fats as well if you can to make lights?
Yes, of course. Yes, because you're hunting them anyway, and if you can use it for multiple purposes, that's especially good, I think.
Yeah.
Hmm. Those candles were also used in the first street lighting, as I mentioned at the beginning of the show, in the 4th century in Greece. Or, well, in Antioch. I do not know how to pronounce that, but it's modern Turkey. Antioch. Well,
Okay.
that sounds logical. But it's in Turkey right now.
Yes.
And they used candles for that. Well, I thought it was quite cool. 1700 years ago, you know.
Yeah. Well, if you think about it though, 200 before Christ, and then wait, what was it? 300 after Christ?
Yeah, the
They
fourth
made
century. So, well,
yes.
give it a number, you know.
So well, but then of course first you need roads if you start to think about streetlights. But even then, it's pretty cool.
Yeah, it is. It is.
Like, did they only use that on main roads or big roads or small parts of roads?
I can imagine it's the city center, but considering the size of cities at that time, it's basically the same.
Okay.
Yeah. But development was quite slow after that. The candles 200 BC, as I mentioned, and the next good improvement was 1780, the argand lamp, and it's not really a lamp, it's just a candle. But the guy, Amy Argand, I do not know how to pronounce that as well, was quite clever. He made it in such a way that there was a better combustion, and therefore you needed less candle to get the same amount of light, if you know what I mean.
Wait, what? But how do you control that?
What he did is he made a gap close to the wick, and by that a better combustion was made. So instead of that an uncontrollable fire, which is just going really fast, you had a more controllable fire.
But so you're saying that there is like a small air gap around the wick?
Yes, indeed.
But then you would say there is more oxygen, so there is like faster combustion, right?
You would imagine that, but he did it in such a way that it made it better. Well,
okay.
The guy probably thought he was revolutionary, but he didn't know that about 12 years later, a guy named William Murdoch invented a new type of lighting, gaslight. Do you know what it is, gaslight?
Well, I suppose I know, but it sounds quite dangerous.
Well, it's basically the same as what you use for cooking, if you know what I mean.
Yeah.
What they did is coal gas, that's hydrogen, methane, and carbon monoxide, which is toxic, if you know.
Mm-hmm.
And they used to light that, and that also gave lighting.
Okay.
The guy was, by the way, quite smart. He was also really involved in the invention of the locomotion.
Also, wow.
He was an inventor and an engineer. I think it's mechanical engineering if you would give it a name.
Kinda. I would say it's like on the edge of industrial design and mechanical engineering.
Yeah, something like that indeed. You know what's interesting about William Murdoch as well? There is a guy with the same name, and he was on the Titanic.
Oh.
Yeah, I was investigating that guy, and there were like 10 famous people with the same name, which makes it hard to Google about him.
Oh wow!
Yeah,
that's quite the coincidence. I mean, how many Isaac Newtons do we have? Or
let me Google that. How many Isaac Newtons?
Right. So, but well, who are famous, right? Or
I can't find any except for the famous one.
That's actually pretty interesting.
It is. But today, when you think about lighting, you're thinking about a light bulb, of course. And the first one was invented in 1841, an incandescent light bulb. Well, it was invented a bit earlier, but in 1841 it was patented, and I think that counts as the invention.
We'll probably have that discussion some other time. It will probably pass the show.
Yeah, it's definitely. But the thing is, some people did already invent it before the guy Frederick de Molin, but they didn't claim it, I guess. And Frederick was the first one to patent the light bulb. Anyway, I wanted to talk about Henry Woodward. He was the 23rd to invent the incandescent light bulb. And he was the first one to actually try to commercialize it. Or, well, he tried to. Because, well, he didn't succeed. And what he did is he sold the rights to Thomas Edison. And we spoke about him before, the one with all the stolen ideas.
Right, we did. Yes.
Yeah, but he didn't steal this one. He bought it from Henry Woodward. And
Okay.
Well, we know him today as the inventor. He didn't invent it. Even Henry Woodward didn't invent it. But, well, he commercialized it, and that's, of course, also really important.
Yes, of course. I mean, it's all nice to have an invention, but if you really want to have it into people's homes, then you'll have to have some way to, well, commercialize it, mass produce it, or in any way.
Yeah,
like,
and by doing that, you make it cheaper, of course, and
yes.
that's really important. Around the same time, a guy called Henry Geisler, he was a glassblower, also was experimenting with, well, all those kind of things. And he was the first one to make a vacuum, which is, well, like really close to a vacuum, 0.25% of standard atmosphere. And he used that to experiment with different gases. And that is the start for the neon lights, actually.
Oh, already then? Wow.
Yeah, but what Geisler did is he was experimenting around with mercury, which is odorless, colorless, and toxic, just like carbon monoxide.
Yes.
Yeah, I don't think he's on the list with people who die from their own invention, but I'm not sure if it's really healthy or not.
I guess not, no. No, it's pretty bad.
Yeah, it is. Yeah, because 40 years after Geisler, the neon was discovered. Not the neon lights, but I'm talking about the gas neon.
Yes.
And that was used in 1910 by some guy named George Cloud. And he thought it was revolutionary. And what's really cool is he shows it at the Paris Motor Show, which is a really, really big show in Paris. And he was like, I can advertise this. Like, look at this. This is cool new lighting. And people really liked that because within 2 years, they were already used for advertising signs. Not like they do in Las Vegas right now, but, well, quite cool, right?
Yeah, I mean, I can imagine how people from like the early 1900s found this really, really cool because the only way you can get colors is by, well, of course, looking at the real world or painting stuff. But now you had a way to actually get very pretty colors in lighting and on the streets, which I guess made life just a little bit happier.
Yeah, indeed. I think neon lights were only white, but if you have a colored glass around it, you can make every color you want to, right?
Yeah.
Only a few years later, in 1927, the first LED was invented, the light-emitting diode. And what's really weird about that is that they could only make one color. In 1962, that's like 54 years later, they could make red light, and that was the first visible light. So in 1927, they couldn't even make light that was visible to us.
Right, yeah, that's, I think I read as well that, I'm not entirely sure about this, but I thought that one Nobel Prize was for making I think a blue LED, because that actually took a long time as well to make.
It did. I've got it in my notes over here. 1989. That's 27 years after the discovery of LED light. That's just mind-boggling, you know?
Yeah. Well, if
you think you've invented something and you can't make a certain color, which is just weird.
Yeah, well, you can artificially get, of course, a color with, like what you said, with filters or anything. But yeah, right off the bat with an LED, it's quite hard to get the right color. And that, I think it has to do with the physics. But I can maybe explain a little bit about that in my part.
Yes, please. But white light is not possible with LED, so you can't use filters. Because white light is a... white light
about that. Yeah.
is a combination of all the different sources, and due to the fact how LED is created, you can't make white light.
Right.
So what they do in televisions is just red light, blue light, and green light. I always forget about that. It's green or yellow.
I think it's green.
Let's hope so. Yeah. So and I want to talk about one final thing, and that's OLED. You see that in all modern televisions, of course, which is organic light emitting diode. But I don't really get how that works. All I do know is that it creates the perfect black, well, as they say, which makes televisions way more nice. But I think you do know a lot more about that. Am I right? As a scientist?
Well, yes, I know a bit more about OLEDs. And so let me first start off with trying to understand why it took so long to go from the first invention of the OLEDs to OLED televisions, which only have been like mass produced, I think, in 2009. And that's not really
that sounds about right, indeed.
Yeah, and that's not even that long ago. And what you have to always remember with these kind of inventions is that they usually start as a proof of concept. People make an LED in the lab or wherever they are making it, but then they only have one LED. And
which is very, very expensive, probably.
Also, yeah, so it's A, very expensive, and B, it's very hard to upskill. So if you want to get this to the masses, then you have to find a way to mass produce it, but also make it cheap enough to be able to like actually sell it and not have, you know, a very big price tag attached to it.
Yeah, those OLED TV screens you see at the on the internet or anywhere are like several hundreds or thousands of euros.
Yes.
And that's already cheap, between quotation marks. You can't imagine what the first OLED would have cost.
Yes, and that's also the reason why the first OLED displays were usually made for very small displays, because there just wasn't a way to make very big displays at a cheap cost.
What is small in your sense?
I would say like your phone, about that
like
size.
That. Okay.
Yeah.
Yeah.
So then let me do another step back and give a quick review of what actually LED technology is, or I mean what an LED is. It's basically just two semiconductors that are stuck together, and you have two parts. One is doped with electrons, and you call this negatively doped, and one is positively doped, as you can say. So electrons are removed from the material, and therefore there are like holes, electron holes in the material. Now,
okay, you could say it's something like a battery with a positive side and a negative side, right?
Yeah, you could compare it to that. The only difference is that both materials are semiconducting, so they don't actually conduct electrons very well. Now, if you stick them together, there is a small region in the middle, that's the depletion layer, and that increases the difficulty for electrons to pass through through the depletion layer to the, like, say, positive side.
Okay.
But this all changes when you apply a certain current. And
okay, so you can increase or decrease the rate at which electrons go through that gate.
Well, actually, because it is a semiconductor, it's not ohmic in the sense that if you apply a current, it will linearly respond with the resistance.
That sucks.
So if you, at some point, if you pass more current through it, the voltage hardly goes up, if I say that correctly, or the other way around. At least it's not like linear.
Okay, so just like batteries, you've got a maximum voltage, which is chemically bounded. Something like that.
I'm not sure if you can compare it to that, but at least the idea is that at some point, when you add more current, the voltage doesn't go up.
Like that. Okay.
Now, I kind of lost where I was in my story. So yeah, so two semiconductors, and then you apply a current, and then the electrons start to flow. They go from the one side to the other. And for some materials, when these electrons combine with the holes, there is some energy left, and this energy leaves the material in the form of a photon.
Okay, and that energy level is of course related to the energy level of the light. And if a certain energy level is produced by one electron, you get one certain frequency of light, which means one color, right?
Exactly, and that is the very reason why it was quite difficult to find the right color, because you have to find the right material that actually has enough like energy left to make blue photons.
You know what? That makes sense.
Okay, nice.
Yeah, it does.
And so that's and then of course when you have the right material, you have to hope that it's not a very expensive material, so you can actually make the LEDs quite cheaply.
Do you know what they used for the blue light? Because I'm now
Um,
especially interested in the blue light, of course.
Let me see if I can really quickly find that, because it's probably one very weird in the like material made in the lab.
Yeah, probably, but I can imagine it has to be like really easy to make because otherwise LED TV screens wouldn't be available since I don't know the year 2000 maybe.
I can't really find where I know what material it is. It's zinc doped gallium nitride, but that's not telling me anything.
No, me neither. Although you should have known that after all the chemistry classes we've had.
Yeah. I'm just gonna say that this is probably very quite complicated material science, and
Let's say that
magic
indeed.
happened. And
Yeah,
now
magic,
we have
which some people call magic that some people call chemistry.
Yeah, indeed. So very smart people thought about materials and tried to develop new materials in the lab, and probably that's the way that the blue LED got commercialized.
Okay, so that's LED, and that got commercialized around the year 2000, if I remember correctly.
Yeah, well, let's say 2000, about that time.
Yeah, the blue light was 1989, and then just a bit after, I imagine.
So, and that is how LEDs are made, or how they, not how they are made, but how they work.
Okay.
And now, of course, we have the magic that is called OLED. And really the only difference is that instead of like inorganic semiconductors, they use organic material.
Yeah, OLED is a abbreviation for organic light emitting diode, so that makes sense.
And the reason why, again, this was, it took us until like 2009 to actually mass produce, is that you can like deposit materials on a substrate, on like a backplate, and that way you can build up the OLED from bottom to the top, or from top to bottom. But methods to mass produce this were not available yet at the time that the OLED was invented in principle.
Okay, when did that come around?
I would say, yeah, so also around the 2000s, especially now, let me look this up, because they use like a combination of technologies, and one is a very important one, which I think has only been recently worked on. So metal deposition, photolithography, and etching. And photolithography,
like
so photolithography is a technique where you put a photosensitive layer on the substrate, and then if you excite it with certain light, it will vaporize. So if you can, for example, put a protective layer on certain parts, then it will not respond to the photons coming in, and therefore you can make like structures. And that is needed to make LEDs, because you need like a three-dimensional shape if you want to build it from top to bottom. And yeah, so photolithography was really important in mass producing OLEDs.
Okay. So what is the key feature of OLED which makes it superior to LED?
Well, there are a couple of things. First off, with today's technology, you can make very big panels in one go. So you don't need all the separate LEDs, which makes the OLEDs usually thinner, and I think also lighter.
That's two main advantages, of course, for customers especially.
Yes, and also, and that is, I would say, is the huge thing here, is that you can make OLEDs transparent in such a way that they are transparent when they don't emit light, and when they do emit light for certain parts, well, you have your display.
Would that technically mean that you can see through your television or through your computer screen?
Yeah, so there are already like I've seen some concepts on the internet where you have a piece of glass, it looks like, and then you put it on and it becomes a television. And this
That's
is
so
pretty
weird.
revolutionary. Yeah, it's weird, but it's also really cool if you start to think about it. Like we mentioned last episode, is I told about where you can like project a display on your front window for
Yeah,
your
I
car.
was thinking about that as well.
Yeah.
Is that already a
Your
thing,
windshield.
or is that just a thing we just came up with?
Well, it's something that is being developed for sure. And with transparent OLEDs, you can actually do this quite easily. Or, well,
And it
relatively
sucks. Otherwise,
easily.
we could have been millionaires, but never mind.
Yeah, no, indeed. It's not... people are already working on this.
That's a shame.
But you can also use it, for example, on your windows in your house. So you can see the weather forecast, or use it on your freezer so you can see when products are expiring or not. You know, the possibilities are endless.
Yeah, that sounds fun.
Yeah, it's and I hope that more people will think about more applications, because I think we will live in a very exciting world.
I'm gonna think about that. That's indeed interesting.
And of course, another application that is maybe not as revolutionary but still pretty cool is that you can also have or deposit the organic layers on plastics, which means that you can have like flexible screens. So
Oh, that's fun.
yeah,
That's like the old flip phone.
right.
Back to the 90s, or whenever that was invented.
But then roll it up, and you know the only thing is that you have to put all the subsequent electronics that come with it will have to be rollable as well, or foldable. But at least the display you can just fold it up.
Oh, that's indeed cool. And by the way, I was surprisingly close to the first flip phone, 1989.
Oh, nice.
Yeah, I just guessed 1990. Yeah, a Motorola model, which is still around at the moment. Anyway, continue.
A couple of things that I found quite interesting to read about is the fact that LEDs, although they seem like a quite, small invention, are still so widely used that you don't even think about it. For example, LEDs started to be implemented into cars around already the 1990s.
Into cars, you mean like how do you call that?
Brake lights?
That was not what I wanted to say, but I think that counts.
The front lights?
The front lights,
right.
Yes.
Yeah. So no, the first implementations were very easy on like the brake lights that were in the back, and then one strip was usually, or like the top strip, which is quite small, was then made of a few LEDs, and that was the very first implementation.
I can imagine that that invention was quite early, since red LED was invented the first.
Yes. So that also makes sense in that regard.
Yeah, so you can implement that way earlier than anything else.
And if you start to think about it, as soon as you also replace the other brake lights from incandescent light bulbs to or halogen lamps, I think, to LEDs, the rise time of LEDs is relatively short. So people can actually respond faster to brake lights because of that. And it might seem small,
that makes
but
sense.
Yeah. But indeed, so incandescent light bulbs are pretty slow, yeah. And another thing, and that is still not super important, but it's quite interesting, is that, for example, on ambulances, if you have LED flashing lights, they actually need so little power that you can just leave the engines off, and that you don't need the battery at all to keep them running.
Oh, that's nice.
Saves a bit of energy, so yeah.
Have you heard about QLED as well?
So yes, I have heard about this, but only when you told me about this about an hour ago.
Yeah, today at college, one of my friends was talking about it. It's a new invention, and Samsung is using it in one of their new televisions.
Yes.
And I found a small quote. Let me read it out loud. The short version is that emissive QLED TVs have the potential to match the absolute black levels and contrast ratio of OLED with better power efficiency, better color, and more. So that's according to Samsung.
Okay.
And that is promising, right?
Yes, that indeed sounds promising, but how that is actually possible, I'm not quite sure. Because
it has something to do with quantum physics.
Okay.
Well, it's in the name. QLED stands for quantum dot LED.
Yeah, and that is, as far as I got, is basically what you said. It's so quantum dots are used, or it's alternatively called quantum dot display, and they use semiconductor nanocrystals. And these crystals...
That sounds complicated.
Well, nanocrystals basically just mean very small crystals, and these they are so small at, like, say, nanometer level that they have different properties from bigger or normal crystals.
So that's why it's called quantum, because also quantum physics is about the really small and different...
Yeah, so it's about the small scale. So, as far as I understood, what happens is you still have an anode and a cathode, or P and N doped semiconductor parts, but the electrons, instead of going through a depletion region, are going through the quantum dots. And these quantum dots are then emitting the photons. And that's how far I understood.
Okay, so it's the same concept, but completely different.
Yeah, well, because with like OLEDs, it's organic layers, and here it's crystals.
Yeah, okay. Huh.
But and that is also one thing I forgot to mention about LEDs, is the reason why LED displays can't really produce black very well is because LED TVs usually have a LED backlight, and then in front of that there is an LCD display, a liquid crystal display. And what you can do with the backlight is either only turn off certain parts or turn it off completely. And well, then you have, of course, no light at all anymore. So usually when you want to make black, you can only like tweak the LCDs in such a way that there is almost no light going through, but you will also have a little bit of light, always have a bit of light coming through.
Yeah, so that's the reason why OLED has way more potential future than LED light. Because LED light is always a bit wider than perfect black.
Yes.
And OLED has the capability of being perfect black.
Yeah, and also one other technology is to use dimming. So of course the LEDs, you can dim LEDs a little bit, but the thing about LEDs is that they're pretty much either on or off. So dimming capabilities are still not great.
So it's like a trick to make it better, but it's still not as good as OLED or QLED.
Yes, and that's pretty much it about the full black. So, but how like the quantum dots still approach the blackness of OLEDs with the benefits of LEDs, I'm not sure how that works.
I guess we will figure that out in the coming weeks, maybe.
Yeah, we can do that.
I mean, I'm interested in this, and I will probably Google some stuff about it. What I did do already is go to YouTube and search for what is QLED, and you find surprisingly few.
Yeah.
The first result you've got is QLED versus OLED, which is better, but it doesn't go like into real things about how it works.
Mm-hmm. I kind of had the same issue with OLED. I tried to figure out like what the production process of OLED actually is, but it's surprisingly difficult to actually figure out how OLEDs are being made. The only thing I know is that like a whole lot of materials are deposited on a substrate and then removed again in the right order.
You know what's the only solution? I think nobody knows.
Exactly.
That's gonna
experts
be it.
knows, but we don't know. Okay, so we have talked a whole bunch about OLEDs, LEDs, QLEDs, but let's try to go back to a bit more other technologies. One thing, for example, I found really cool to learn about was the gravity light. Have you heard about this?
I have, but I can't really remember what it is. Continue.
Okay, good. So the first time I got introduced to the gravity light is when I saw a video from Destin from Smarter Every Day. And the idea is actually really simple. What you do is you pick up a bag, you put some rocks in it, you hang it onto a hook, and then it slowly falls down, which generates energy, and then you have light. And that's of course the very, very short explanation.
Okay, so we can say it's the gravity light isn't really an invention about lighting, but it's an invention about how to get electricity to get a light.
Yeah, and
because I can imagine they are just using LEDs or something.
Yeah, and that is the gravity light really comes down to a bunch of combinations coming together. One thing
like how?
Okay, so let me try to take a step back. The working principle is about the same as an old cuckoo clock. So where you have like hanging weights and you pull them up and they slowly fall down, and with that you have enough mechanical power to power your clock.
Yeah, they gain just as much energy as friction and air resistance does for the clock.
Well, it works with, and Destin explains this way better than I ever could in his video, but this bag falling down powers a drive sprocket, and this sprocket rotates very slowly because it has a high torque. And because it has a high torque, let's say it like this, you need to add a lot of energy to the system to make it turn. And therefore it's basically that is where you get the slow speed from. And this is with a very intricate system converted to a high speed, low torque output through the works of gears and sprockets.
Okay. So by doing that, they can save energy, or how do you call it?
Well, they generate enough energy to power an LED, and that is where the combination of LEDs and this mechanism comes together. Is you don't really generate that much power, but for LEDs you don't need that much power.
That's quite smart. So you don't have to fill the bags again. You don't have to lift all those rocks. You can do it once an hour, or what am I talking about?
Yeah, that's a good question. It's once every 20 minutes. It doesn't sound like much.
More often than I would
yes.
want to.
But imagine this. The alternative in Africa is have very dangerous other lighting technologies. Let me see. I think kerosene lamps they use. And let's say kerosene is highly flammable. So, to have this
toxic and
yes, to have this as an alternative is a really nice solution for that problem.
It is. The guy who invented this, kudos to him.
Yeah, I think he kickstarted the project, and now he has a company that just keeps developing this technology. And let's hope it will save many more lives.
Yeah, let's hope so.
So that is about it for my part.
Today we've learned a lot.
Yes. Yeah,
LEDs, OLEDs, QLEDs. What will come in the future? Who knows?
Hopefully I lighted up your world, and maybe you guys can light up our world and go to our website and show us some support.
Did you just think of that?
I just thought of that.
You're brilliant.
Thanks. So what is our website?
ageoftechpodcast.com.
Yes, and where can people find us as well?
Ooh, that's always a hard question because we haven't done this yet. Twitter.
Yes.
iTunes. And
YouTube.
Your podcast app. Oh, YouTube. I forgot about YouTube.
Yes.
Yeah, I think that's about it.
Okay, and that's all under the name Age of Technology, except for Twitter, because we don't have a Twitter yet.
You can just follow our personal accounts, I think.
Yeah, let's say Mr. Engineering Guy, because I'll retweet most of his stuff anyway. But that's for...
Yeah, for updates you can follow me.
Yes.
So, thank you for listening, and I'll see you around.
Yes, goodbye.
Adios.